What is going on YouTube? Just helping you out here. And for today's video, I will be doing Chapter 12, Problem 2 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 12 is all about equilibrium and elasticity, and in Problem 2 we have an archer, and we're asked to find the angle in the string when the archer is pulling back. And so the first thing that I want to do for this problem is draw a diagram, just to have a visual and make it a little easier to understand what exactly we need to solve for here. And so I'm going to draw an XY coordinate. So let's say this is the X and this is Y. And so if we picture a bow and arrow, we're going to have one half of the string like that, the other half like that, and we'll have a force of the archer pulling back. And so we'll have tension in the string, and we're told that this force is equal to tension in the string, so we can also call this tension in the string. And so here we have an angle, and here we also have another angle, where these are the same angle. And so when this is occurring, we are in static equilibrium. So as the archer is pulling back the string, everything is still. And so what we can do is a force balance in the x direction. So the sum of the forces in the x is equal to 0 because everything on the right side here is equal to everything on the left side. And so we can sum that up. And so to find the x directional force, we can take tension times the cosine of theta. And so we're going to have tension cosine theta for this top piece, and we're going to have another tension cosine theta for this bottom piece, and then we're going to have a minus t for this tension in the negative direction. And again, all that must be equal to 0. And so we can add these two up and move this t to the other side, and so we have 2t cosine theta is equal to t, and then we can divide by 2t, so we get cosine theta equals t over 2t. Our t's will cancel and we just get 1/2. And so now we can find our angle by doing the inverse cosine of 1/2 equals theta, and so theta is equal to 60 degrees. But in the problem we're asked what is the angle between the two halves of the string, which is this entire angle right here. And since this piece is theta and this piece is theta, what we're really looking for is 2 times theta. And so our angle is equal to 2 theta, which is equal to 2 times 60 degrees. And so our final answer is angle is equal to 120 degrees. So that's it for this video. If you found it helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.